In this video, I want to talk about the idea of using reference angles to evaluate trig functions in any quadrant. Okay. On the board, I've drawn a angle theta that lies in quadrant 2, and we rotated an arm of length 5, and the corresponding point here is a negative 3, 4. Right? So we know that cosine of theta is the x-coordinate over the radius, which here is a negative 3/5. Right? But if we look at this picture, and if we think about the right angle that, or the right triangle rather, that is sitting here in quadrant 2, right? This angle here, called a reference angle, lies somewhere between 0 and 90 degrees. Right? And what I could do is I could flip this triangle over into quadrant 1, and what happens is, instead of a negative 3, 4, right, just flipping over the y-axis, we make our x-coordinate positive. Right? So this triangle here is a mirror image of this triangle here, just flipping over the y-axis. Right? So cosine of my reference angle is 3/5. Right? So I know that any triangle in quadrant 2 can be looked at in terms of a triangle in quadrant 1 if I just think about making the x-coordinate negative whenever I need it, right? And we definitely need it for cosine. So what I could write is the cosine of theta is negative the cosine of the reference angle, and we're going to get negative 3/5, right? Which is exactly what we computed just thinking about quadrant 2 and the definition of cosine. Right? So let's look at another example. What if I take an arm of length 5 and rotate it into quadrant 3 so that it lands at the point negative 3, negative 4. Right? Well, again, we have a right triangle sitting here, and just in terms of the triangle, this is some this theta prime here is some angle between 0 and 90. I can think about a copy of this triangle sitting in quadrant 1. The radius will be 5, and the points now, right, in order to get this triangle sitting up here in this position, I just need to make the x and the y coordinate positive. Okay? So I could compute, let's say, the tangent of theta. Right? Over here we know what to do, just take the y coordinate and divide by the x-coordinate, and we get 4/3. Or I can think about tangent of the reference angle using this reference triangle, and again I get 4/3. Right? And because tangent is positive in quadrant 3 and quadrant 1, I can compute the tangent of this angle by looking at the positive tangent of the reference angle, equal to 4/3. Let's try another one. What if my rotation was in the negative direction? It was a rotation of an arm of length 5, and it landed at the point 3, -4, right? Well, again, there's a right triangle sitting here. I can think about this reference angle, again, somewhere between 0 and 90 degrees. And I can put a copy of this triangle in quadrant 1 just by making my y-coordinate positive, right? Changing 3, -4 to 3, +4. So if I wanted to compute the sine of theta, right, ignoring this reference triangle idea, we would just take the y-coordinate and divide by the hypotenuse. And we get a -4/5. But if I use my reference angle, right, sine is going to be 4/5, but the sine is negative in quadrant 4, and of course it's positive in quadrant 1. So if I wanted to use my reference angle, right, I merely need to recognize that I need a negative in front of the sine of theta prime. So when we use reference angles, we try and capitalize on the idea that triangles in quadrant 1 can just be folded over and down to match the reference triangles that appear in our rotations.